There are some rules needed to build electronic configurations of atoms. The first rule is the Aufbau principle. Electrons are added to the lowest energy orbitals before moving to the higher energy orbitals. Let's build the electron configuration of some atoms. The hydrogen atom has only one electron, so it is easy to do its configuration. Hydrogen has one valence electron in the s orbital and no core electrons. The next element in the periodic table is lithium with 3 electrons. We can place 2 electrons in the lowest energy orbital, the 1s orbital, and the third electron in the 2s orbital with higher energy. This electron is the valence electron. The 2 electrons in the 1s orbital are the core electrons. Sodium has 11 electrons. We can place 2 in the 1s orbital, 2 more in the 2s orbital, and 6 electrons in the p orbitals. We are left with only 1 electron that we can place in the next s orbital. This last electron is the only one in the outermost shell, and it is the valence electron. Look at the electron configuration of hydrogen, lithium, and sodium. Do you notice something? All 3 atoms have 1 valence electron in an s orbital. The electron configuration of the outer shell is the same for all 3 atoms. The fact that the electron configuration is the same can make us predict that their behavior will be similar. For example, we know that sodium explodes in water, so does lithium. We know that sodium forms sodium chloride, and so does lithium form lithium chloride. As it is, we have just found out that if we know the electronic configuration of an atom, we can predict some of its properties. There is something else that we can observe. Hydrogen, lithium, and sodium are all in group 1 of the periodic table, and all have 1 valence electron. If we look at the electronic configuration of beryllium and magnesium, we can notice that they both have 2 valence electrons. They also are both in group 2. We can derive that the group number corresponds to the number of valence electrons.